Problem number 22, we want to find the value of x, the measurement of arc BEC, and the measure of arc DA. So the first thing I notice in this picture is this segment right here. It goes right through the center of the circle. So what would we call that? A diameter. And it cuts my circle into two semicircles. So how many degrees would arc DEB be? 180. Well, arc EA is 56 degrees because it's the same as the measure of its central angle. And arc AB is 57 degrees because, again, it is the same measure as its central angle. So I know if I take 2x minus 7, that arc up there that is DE, plus 56 degrees, plus 57 degrees, that should all add up to how much? 180. So then we're going to combine our like terms together, negative 7, 56 and 57, which is going to add together to give me what? How much? You forgot the minus 7 part.
106.
106. So 2x plus 106 equals 180. And then we'll minus 106 from both sides. What is 180 minus 106? 74, and then we cut that in half to get rid of the 2 in front of our x. And we get 37 for x. All right. So now we need arc BEC. So I'm going to start at B. We're going to go in the direction of E, and then all the way around here to C. That is almost the entire circle. It's the entire circle except for how much? Except for these 99 degrees here. How far is it all the way around a circle? 360 minus the arc that we're leaving out, which is 99. And what does that give us? 261. And then the last piece of this question, we want to find arc DA. So from D right here around to A over here. That's almost half a circle. It is half a circle minus how much? Minus 57. So 180 minus 57 gives us what? 123. What else would you guys like to see?
21.
Number 21, absolutely. We're going to change from radians into degrees. So we take our radian measure, 3 pi over 4. We times it by our conversion factor. When we're going into degrees, we have 180 degrees on top and pi on the bottom. When we're going the other way, when I have degrees and I want to turn it into radians, I use the same fraction but flipped over. Whichever thing I'm going into goes on top. So if I want degrees as my answer, degrees goes on top. If I want radians as my answer, then pi goes on top. We're going to multiply top to top and bottom to bottom, but my pi's cancel each other out. So I've got 1 on top and 1 on bottom. So 3 times 180 gives me what? 540. So 540 degrees. And then I still have that 4 in my denominator. What is 540 divided by 4? 135. So 135 degrees. Part B, we take 2 pi over 3 radians. We multiply that by 180 degrees over pi. Numerator to numerator, denominator to denominator. My pi's cancel each other out. So 2 times 180, that is 360 degrees. And then when I take the 360 and divide it by the 3 that's in the denominator, I get what? 120. All right. What else would we like to see?
19.
You said 19, and you said 19. Perfect. Same question. An inscribed angle has its vertex on the circle. So this would be an example of an inscribed angle right here, angle CDG. A central angle has to have its vertex on the center. So like this one here, angle HAD or DAF. A tangent line touches the circle in exactly one place. So this right here, this line, only touches the circle right here. So I can call that line BH, line HJ, or line JB. I'm going to call it BH. And it is a line, so I put my arrows over the top. That point that I circled where it's touching the circle, where the tangent line is touching the circle, this is called the point of tangency. So that is the answer to part E right here. That is point H. A secant is a line that goes all the way through my circle. It can go all the way through on just one side or both sides, as long as one piece of the chord extends beyond the circle. So BD, or I could call that CD, would be a secant. It would be line CD. If HF, which is a diameter, were to extend beyond, then that ray would also be a secant because it goes past the boundary line of the circle. It's okay if it only does it in one direction. It just has to pass through the circle in at least one point, and the other point has to either pass through or touch the circle. And then a chord has its endpoints exactly on the circle. So segment CD would be a chord, but line CD is a secant. Or we could say segment DG. Or my diameter, segment HF. Notice that if it is a chord, it has to be a segment. It has to have the dash over the top with no arrows. What else would you guys like to see? 23? Absolutely. Find the value of x. Well, this angle right here, QSR, is inside my circle. The measure of an inside angle is equal to 1/2 times the sum of the two arcs that it intercepts. So one arc that it is intercepting is right here, 20x. And then the other arc that it intercepts is actually the one that is intercepted by its vertical angle over here, this arc here. So 50 degrees and 20x. Those are the two angles that we're going to add together. So the measure of my inside angle, that is 65 degrees. So I'm going to put that in the place of my inside angle, is equal to 1/2 times the sum of these two arcs, 50 plus 20x. I want to get rid of this 1/2, which I could do by distributing, or what's another way I can get rid of fractions? Multiply by the denominator. So we're going to multiply both sides by 2. It's going to cancel out that denominator there. What is 2 times 65? 130. So 130 equals 50 plus 20x. Then we're going to subtract 50 from both sides. What is 130 minus 50? 80. 80 equals 20x. And then we divide both sides by 20. And x is 4. What else are we doing?
24.
24. Sounds good. Find the value of x, assuming that lines that appear to be tangent are tangent. What does a tangent line do? How will I know if something is tangent? Touches the circle in exactly one spot. Well, this line segment right here touches my circle in exactly one spot. And this line segment right here also touches my circle in exactly one spot. And then they come back here, and those two tangents touch each other. Two tangent lines that share a common endpoint like this are congruent to each other. So to find x, we're going to take 2x minus 5, set it equal to x plus 6, and then we're going to solve that for x. So x is to the same side first, minus your x's. 2x minus x gives me x. So I have x minus 5 equals 6. Then we add 5 to both sides, and we get that x is what? X is 11. What next? 25? Absolutely. 25, we need to find the measurement of angle SXW. SXW. So we're looking for this angle right here. There's a couple different ways you can go about this, but I'm going to use the method that has us using arcs and angles, inscribed angles. I'm going to need to figure out how big this arc is, because that's the arc that's being intercepted by angle SXW. And the measure of angle SXW is equal to 1/2 times the measurement of arc SVW. So let's look at the angles that we do know. I have this 36-degree angle here, and the arc that it is intercepting is arc WX right here. And so arc WX is going to be twice as big as that 36-degree angle. So 2 times 36 degrees, that gives me 72 degrees for this arc. And then we also know this angle right here, so I'm going to follow that out to see what is the arc that it is intercepting. That's this arc right here, SX. SX is going to be twice as big as the angle, so 64 degrees times 2. That gives me 128 degrees for this arc. How many degrees is a whole circle? 360. Well, if I add the pink one, the yellow one, and the orange one together, that's all the way around the circle. So I'm going to take 360 degrees. Come on. Yep, 360 minus 128 plus 72. What is 128 plus 72? 200. What is 360 minus 200? 160. So this arc here is 160 degrees. The measurement of angle SXW is half of that 160 degrees. What is half of 160? 80. So SXW is 80 degrees. All right, let's do one more from Module 10, and then we'll go and look at Module 11 questions. What would you guys like to see? 28? Absolutely. Oh, went too far. 28, there we go. This angle out here, is that inside my circle? No, that is an outside angle. We did that problem earlier that was an inside angle. We said the inside angle was half of adding the two arcs together. An outside angle is equal to half of the difference of the two arcs that it intercepts. So arc minus arc. So let's find the arcs that it is intercepting. So here's my angle coming out here. That means it is intercepting this arc right here, 167 degrees, and this arc right here, 69 degrees. So those are the two that we're going to subtract. This is angle F. So the measurement of angle F equals 1/2. And then I subtract these two. It's always bigger minus smaller. So 167 degrees minus 69 degrees. What is 167 minus 69? 98. And then what is half of 98? 49. I might actually have time for one more in the Module 10 stuff. Is there one last Module 10 question you guys want to see? You said 29? Sure. It says segment PA and PB are tangent to the circle. When a line is tangent to a circle, then right where it meets the radius of the circle, it forms a right angle. So angle PAO is a right angle. And the same thing is happening down here with tangent PB. Where it hits the radius, it forms a right angle, so PBO. Then it tells me that segment PA is 24 inches. Tangent PB is going to the same circle, and it's coming from the same point. So what do we know about PA and PB? They're the same. So if one of them is 24 inches, the other one is also 24 inches. And then it says that segment OB is 12 inches. What part of a circle would we call segment OB? A radius. And what do we know about all the radii in a circle? They're congruent. So OB is 12 inches. That means that OA is also 12 inches. They want us to find segment PO. What did we just make right here? Right triangle. How do we find a missing side on a right triangle? Pythagorean theorem. A squared plus B squared equals C squared. C has to be my hypotenuse. What's the hypotenuse of that right triangle? PO. It's opposite my right angle. So I'm going to put PO in the place of C. That means 12 and 24 have to go in for A and B. Order doesn't matter. So I need 12 squared, and I'm going to add that to 24 squared. What is 12 squared? 144. 24 squared? 576. And what do I get when I add those two together? 720. And then we take a square root of both sides to cancel out the squared on segment PO. Let's go ahead and put this one in decimal form. 26.833, and that would be inches for segment PO. All right, let's move on to module 11. What would you guys like to see from module 11?
32.
You said 33? 32, yes, absolutely. Number 32, and by the way, before I go any further here, if you guys don't have all of the formulas from 11A and 11B, I would highly recommend getting them on your notes sheet. You are cheating yourself out of several points if you don't have the formulas on your notes sheet, on your cheat sheet to use. If you need those formulas, first of all, the 11B formulas, that was on the half sheet that you guys had to use on the test. You should have that half sheet somewhere in your notes packet. If you need another one, it's very top paper over here in that red organizer. The 11A formulas are at the very back of the 11A notes packet. If you don't have that anymore, you can't find that, you can go look at April 18th on Canvas and go through that slide presentation. It's on slides 9 and 11 on April 18th, so you can go find all those formulas. Is it an emergency? Yes. All right, so the area formula for a rhombus is 1/2 diagonal 1 times diagonal 2. So that's the first thing that we're going to find here, because we know exactly how big those two diagonals are. You're welcome. One of them is 72 inches, and the other is 96 inches. So then we pop that into our calculator, and we get what for the area? 3456. That would be inches squared. All right, now the part that is slightly more complicated. We need to find the perimeter of this rhombus. What do you know about all four sides in a rhombus? They are all congruent. So if I can figure out how big one of them is, I know how big all four of them are. So we've got these two diagonals. What special thing is happening where those diagonals cross each other? Right angle and bisecting. So we have a right angle here where those are crossing each other, and they're cutting each other in half. Well, what's half of 72? 36. So this is 36, and this is 36. What's half of 96? So we have 48 here and 48 here. So I'm going to look at just one of these right triangles. What can I use to find the side of that right triangle? Pythagorean theorem. A squared plus b squared equals c squared. What goes in for c? Yeah, that's our missing side, so let's just keep that as c. Or you can call it x if you want to. So in for a and b, we put what? 48 and 36. Does not matter the order there. So we have 48 squared plus 36 squared. What is 48 squared? 2,304. What about 36 squared? And then we add those two together and we get what? 3,600. Then we take a square root of both sides. Does this come out to be a nice, pretty whole number? Yes, it is 60. So this side is 60. This side would also be 60. 60 and 60. So how do I find my perimeter then? 60 times 4. Which gives me 240. And what kind of units would we have with that? Inches. What else would you guys like to see? Number 30? Absolutely. This is another formula you definitely want to make sure to have. This is the trapezoid area formula. Area of a trapezoid is 1/2 the height times base 1 plus base 2. This is the only area formula that has addition in it. Every other area formula has only multiplication in it. So we know that the area of this trapezoid is 85. So 85 equals 1/2 times the height of 5 feet times base 1 plus base 2. Well, one of the bases is 14. And we don't know how big the other base is, so I'm just going to leave that as base 2. All right, we need to get rid of the 1/2 and the 5. I could always find half of 5, but is that a whole number? No. Then I'd rather get rid of that fraction a different way. Let's multiply both sides by 2 to get rid of that fraction. What is 2 times 85? 170 equals 5 times 14 plus base 2. We need to get rid of the 5 now. What operation is connecting the 5 to this other set of parentheses? And so how do we undo that? We're going to use division. Divide both sides by 5. That cancels the 5 on this side. What is 170 divided by 5? So 34 equals. Now over on the right, I don't need the parentheses anymore because there's nothing else over there except this addition, 14 plus base 2. Then I subtract 14 from both sides. What is 34 minus 14? 20. And what kind of units should I put with that? Feet. All right. What else are we looking at? Number 33. Sounds good. The area of a kite is 120 feet squared. If one diagonal is 12 feet, find the other diagonal. The area formula for a kite is exactly the same as the area formula for a rhombus. 1/2 times diagonal 1 times diagonal 2. The area is 120, so we're going to put 120 in the place of A. And then 1/2. One of those diagonals is 12 feet, so I'm going to put 12 in for one of them. And the other one I'm just going to leave as a variable. I'm going to leave diagonal 2. Now this one I do just want to figure this out. What is half of 12? 6. So I have 120 equals 6 times diagonal 2. What next? Divide both sides by 6. What is 120 divided by 6? And what kind of units should we put with that? Feet. All right. We got 15 minutes left. I have enough time for bare minimum 3 more problems, depending on how difficult or involved it is, for as many as 6 more problems. What would you guys like to see next? 35? Absolutely. Find the area of the triangle. Well, I can do 1/2 base times height if I know the base and the height. I know the base of this, but do we know the height of this triangle? Then I can't use 1/2 base times height. What's the other triangle area formula that we know? 1/2 AB times the sine of angle C. So A and B have to be sides of the triangle. Well, here's one side, 34.5, so we're going to call that side A. Here's the other side that I know, so we're going to call that side B. And angle C has to be the angle in between those two sides that I'm using. What's the angle in between those two sides? 37 degrees. So here's angle C. So area is equal to 1/2 times 34.5 times 20.8 times sine of 37 degrees. Now what does that give us for the area? 215.931. They didn't give us any units, so you can just leave that part off, or you can write units squared. Number 34 sounds good. Formula for arc length of a sector. Arc length of a sector is equal to the fraction of the circle that we are looking at times 2 pi r, which is how we find circumference. The fraction of the circle that we're looking at here, we have 75 degrees shown out of how many total degrees? 360. So 75 divided by 360 times 2 pi times the radius of 14 meters. And then we pop that into our calculator. We get an arc length of what? Yes, 18.326, and we put the unit of meters on that. And then the area of a sector is the fraction of the circle that we are looking at times pi r squared, the area of a circle. Once again, we are looking at 75 degrees out of a total of 360 degrees times pi times that radius of 14 squared. So then we take this, we pop it into our calculator. And we get what? Yes, 128.282, and that would be meters squared since it is area. Nicely done. We still have 11 minutes as soon as Jacoby gets back. Yes. 37, absolutely. Find the volume and surface area of the pentagonal prism. Thank you, sir. So to find volume of a prism, we need the area of the base times the height. What shape is the base? It's a regular pentagon. How do you find the area of a regular pentagon? Guys, if this isn't on your formula sheet, on your cheat sheet, you absolutely need this on your cheat sheet. How do you find the area of a regular pentagon? 1/2 times the apothem times the perimeter. So 1/2 times, do we have to go and find the apothem here? Nope, they gave it to us. How big is it? 7.6. Times the perimeter of that base. What shape is the base again? Pentagon. How big is each side? 11 feet, and it's got how many sides? 5. So what is the perimeter? 55. Number of sides, 5, times the length of each side, 11 feet. We get a perimeter of 55 feet. And then we multiply that by the height of the prism, which is the distance between the bases. What is the distance between the bases here? 12 feet. So here's the height of my prism. And then I grab my calculator, 1/2 times 7.6 times 55 times 12. 2,508, 2508, and that would be feet cubed. Surface area for a prism. We have two bases, so 2 times the area of the base, plus our lateral area, the perimeter times the height. Our base is a regular pentagon, so 1/2 apothem times perimeter, plus the perimeter of the base times the height. So we have 2 times 1/2 times that apothem of 7.6 times the perimeter of 55 plus the perimeter, which is 55, times the height of the prism, which was 12. We're going to put this in the calculator in pieces. Let's find the area of those two bases first. What is 2 times 1/2 times 7.6 times 55? 418. What about the lateral area? 660. And so then we add those two together to get a total surface area of how much? 1,078 feet squared. What are we looking at next? Yes. 40? Absolutely. Find the volume of the square pyramid. Volume for a pyramid is 1/3 times the area of the base times the height of the pyramid. What shape is the base here? It's a square, so 1/3 times side squared times the height. How big are the sides of that base? So 1/3 times 11 squared times the height of the pyramid, which is 10. .333 kilometers cubed. All right, 5 minutes left. That's probably 2 more problems depending on length. You said 42? Absolutely. Identify the shape of the cross section if sliced parallel and perpendicular to the base. So if I cut it parallel to the base and I look at that cross section, it's going to have the exact same shape as the base. I'm just cutting it clean through. What shape is that base? Hexagon. If I were to slice this perpendicular to the base, so like this, we're going to see a rectangle, yes. Right. What else would you guys like to see? 38? Absolutely. Number 38, find the surface area and volume of a beach ball with a radius of 10 centimeters. What shape is a beach ball? Sphere. Surface area for a sphere is 4 pi r squared. So 4 pi times our radius. What's our radius? 10. So 4 pi times 10 squared gives us what? Yep, 1,256.637 centimeters squared. And then volume for a sphere is 4/3 pi r cubed. So 4/3 pi times 10 cubed would give us a volume of 0.79 if we round it out to 3 places, because it's going to round up there. 4,188.79 centimeters cubed. I think I have enough time for one more if it's very, very short. I have posted videos of every single other class period today, and I will do the same here. I am also, for the first time, putting down exactly which problem numbers were gone over in each of the classes. So I believe that the only problem number that will not be on some video, at least one, is number 39. Would you guys like me to do 39 real quick so that everything is covered? Okay. Find the surface area and volume for the right rectangular prism. Well, volume for a right rectangular prism, we need area of the base times the height. And because it is a rectangular base, we're going to do length times width times height. So my length is 6. My width is 8, or you could switch those around. It doesn't really matter. And then the height is 4. 6 times 8 times 4 gives me a total volume of 192 yards squared. Surface area. We need, yep. Yes, thank you. Cubed. Thank you for catching that. Surface area, 2 times the area of the base, plus the perimeter of the base times the height. Again, we do area of the base by doing length times width, so 2 times length times width, plus the perimeter of the base times the height. So 2 times 6 times 8, plus, let's see, we have 16 and 12. Perimeter of the base would be 28 times the height, which is 4. The area of the bases is 96. The lateral area is 112, giving us a total surface area of 208 yards squared. Please keep in mind you guys will be turning in your green cheat sheets tomorrow at the end of class, and then I will give them back to you on the very last day. Rodney, hold on.